So anyway, today's subject, we're dealing with remote monitoring and control. And as I've looked back over the last 2 years, as we have been doing these webinars, we've done 19 webinars covering a wide range of topics. And the focus of these webinars, we've wanted to provide useful information that you, our friends, and our clients can take away. And so I think today is going to be an excellent example of that, how we're taking technology and we're deploying that on sites to save our clients money and make them more efficient in terms of their operations. So let me introduce our panelists today. Today we have David Hostetter and Phil Carrillo with us. And Dave is a professional engineer. He's the business manager for our remote monitoring and control group. He manages the group's work across the United States and internationally. His experience includes remote monitoring and control systems engineering, construction, and operation, landfill gas and leachate engineering, mechanical engineering, all kinds of engineering, David. He's a registered professional engineer in Pennsylvania. He's a certified energy manager. He's lead accredited professional. And he actually won the Waste 360 40 and Under Award, as well as being a control engineer and an award through the Control Engineering magazine. So that's pretty impressive, David. Phil Carrillo is the director of our remote monitoring and control systems group. He has 20 years of experience in groundwater monitoring systems, water supply systems, solid waste and landfill gas management, including remote monitoring, supervisory control and data acquisition. For those of you who know that it's typically referred to as SCADA, control systems, and the operation and maintenance of landfill gas collection and treatment systems. He's managed all aspects of gas collection and control systems. His unique combination of field operations and management experience and control and systems and technical experience adds, we think, tremendous value to our clients. He's designed hundreds of remote monitoring and control systems. And I think today, as we go through this, you'll get a sense of some of the examples that he has been involved with, as well as Dave. So Dave, I think you're kind of leading us off, and so I'll turn it over to you.
All right. Thank you, Bob. So we'll start in with some flavor on what RMC is. So RMC, it's an acronym. It means remote monitoring and control. RMC, our purpose is to work with and listen to our clients to leverage technology to lower operations and maintenance costs and reporting costs, lower the environmental and health and safety risks at the facilities that we work at, and improve the quality of life for the engineers, operators, managers, owners, and the local communities around these facilities. So at a high level, that's what we do. I thought another interesting way that we could look at this is through this word map that you see here on the screen. So you can see that a couple things pop off the screen here immediately. Obviously, monitoring is a big part of what we do, and then control and this aspect of doing this all remotely. So we try to get all of our systems set up so that they're very easy to use and that they provide a lot of benefits to our clients. They're connected to many, many, many different things across the facilities that we're at. One of the ways that we like to put it is that really anything that you can think of that we could attach a sensor to or monitor or get a reading on, or anything that has an input or output associated with it, we can get connected up to it, and we can provide data and actionable intelligence from that. So some of the things that we get connected to are also shown here on the screen. We look at stuff like methane and flare stations and tanks and pumps and headers and plants and flares and wellheads. And we use technologies like drones and alarming systems and all sorts of different sensors. So hopefully this kind of helps set the stage for some of the things we'll be talking about here. You can jump to the next one, Diane. And really at the heart of what we do is that we want to present this concept that we create an overall operational dashboard for your facility and your equipment. Through this operational dashboard, like the one you see here on the screen, you should be able to pull up your interface and know exactly how your key equipment is functioning at any point in time and make whatever changes you need to make, and ideally remotely, based on the data that you're presented with. So these dashboards should help you to be proactive instead of reactive. You'll hear me talk about this point throughout the presentation and set again at the heart of why we're here and the benefits that we provide. And really this dashboard should be your one-stop shop for operating your facilities. So you'll see some examples of this throughout the presentation. And Phil, is there anything you want to talk about here with what we're looking at on the screen?
We designed these screens to help out the technicians and managers. If you have a shutdown, you can quickly identify the issue, and we really get our clients' feedback, and these interfaces are driven by our client. It's not us, it's what they need to run their facilities.
Yep. All right. So let's jump in with some of the key functionality here. We'll go from the key functionality to some applications and some case studies, and then we'll cover new developments. And again, as a reminder, as Diane said here, we want this to be interactive. So if you have any questions, please use that Q&A function to send us your questions, and we'll tackle them here as we move through. So the first piece of key functionality that we want to cover here is this concept that when you collect data automatically and store it in a place where all stakeholders can access it, you create one source of truth, retaining all of your legacy and institutional knowledge. So an example of this is shown here on the screen. What we're looking at is an automatic SSM, or startup shutdown malfunction report. And this is something that we generate based off of what we're gathering data-wise out there at this flare station. So in this example, when you need to produce an SSM report, you don't have to figure out who knows why the flare shut down on October 4th. You and other stakeholders can log into the cloud-based SCSRMC system and see it for yourselves. Phil, is there anything you want to talk about here with the SSM report?
So we also take it a step further and fill out the actual, this is a running log, but we'll fill out the actual form for the reporting department to submit their quarterly reports.
Yep. And you can do that right here through the interface by entering information into the notes section and checking different boxes, and then hitting that nice download button there to get the data out. So the next piece of functionality that we want to talk about is the whole issue that really everyone is dealing with inside of our industry and outside of our industry. And that's that employee turnover is affecting really everybody. And RMC gives you several ways that you can decrease the impact of employee turnover on your operations. So the first way is that RMC systems improve the quality of life for the employees that come in contact with these systems. You no longer have to go to the facility to make a change or check on your equipment if you have an RMC system. You can do it all remotely. The days of having to drive into the facility in the middle of the night to restart a flare are done. And I'll let Phil talk you through the two examples here that we're looking at on the screen in regards to that.
So we have a high condensate level and a shutdown, and we can quickly identify what the problem is. And I love telling this story of a good friend and colleague. He had a shutdown on Christmas. He's opening up presents, and sure enough, the flare shuts down. And this is a new RMC system. Before, they had to drive an hour and a half to the site to troubleshoot and start it back up. So in this case, it was a power failure. He simply called it up, went through the safety checklist, and he restarted it. And he was back with his family, opening up the presents, and it was a quick 5-minute detour on Christmas. And it also saved the client before that he would pay for the drive time there, back, and it's all streamlined now.
Yep. And you can see those two examples here on the screen of what these remote interfaces look like. So on the left-hand side, we've got our kind of mobile phone based interface. You're looking at an iPhone there on the left, but it also works on Android devices. Anything that's got an internet connection and HTML5 browser, we can get this system working on. You can see there the reset button that Phil was talking about, and that's where the person would have gone in and hit that to bring the flare back online. On the right, we've got our iPad version of this, and this literally is the same interface, and it just changes in size based on what device you're looking at. So on the right-hand side, you can see some of our key performance indicators or KPIs. They're there on the left. We like to use the concept that green is good and red is bad throughout our interfaces. So the purpose of that is that when you log in, you're presented with the data that you need, and you know right off the bat whether you're good or green or bad or in the red. And generally, one way to think about it is that if you're in the red, you'll get an alarm as well. And you can see that in the upper right-hand corner of the screen there where it says 1 alarm. And then you can also see there on the right that we've got graphs of how the system has been operating over time. Now, you probably all know this, but we've got templates set up for all of this. But getting back to what Phil was saying before, we customize all of these systems to meet your needs using those templates. Now, the second point here to turnover management is that when a new employee starts, they have all the information they need at the touch of a finger. You can see that here on the screen. They don't need to figure out where the stuff is. They can go to one spot for everything. They can go on here and see how their flare is operating, see how their pumps are operating, to Phil's point, see how their condensate systems may or may not be affecting their flares. We'll be looking at an example here in regards to that. And the third point is that as more technology is deployed to the landfill space, you and your team can do more with less. The days of needing to go out and get frequent manual readings on equipment are a thing of the past. Your environmental data technician can become your future environmental compliance manager. And I know that this concept is something that we're trying to do here at SCS, and really everyone is trying to do throughout the industry, that we're trying to do more with technology. And again, get back to that point of trying to work smarter rather than harder and be proactive instead of reactive. We feel like these RMC systems really help hit on all those points. So with that, why don't we jump into some applications? And we'll talk through these applications and how you can use them to create efficiencies in the work that we do. So what you're seeing here on the screen is our lowest cost RMC option. It's called RMC Lite. It's a low cost templatized version of RMC. It connects to some sort of data recorder that's out there on the site. We can connect to all sorts of different things, whether it's the Yokogawa that's there probably in your flare, or maybe it's a PLC in your leachate treatment plant, or maybe it's something else. Maybe it's an HMI somewhere else. And really how this works is that we get that data off of that data recorder and we automatically upload it into RMC Lite. And RMC Lite provides you with data recording, visualization, and reporting. You don't need to go out to that data recorder anymore to get your data off of it. The files are automatically uploaded daily, and this can be used for any type of data, whether it's a flare station data like you're seeing here on the screen, or a tank, or a pump, or an air compressor, any of those things that we were talking about before. We can gather data from them quickly and efficiently and cheaply. Phil, is there any thing you want to point out here on the screen?
Just the fact that our reporting department, so when there's gaps in data, typically they would have to go to the recorder at the end of the quarter, get the data, and then they were scrambling to figure out, a power outage. With RMC Lite, all your data is uploaded, and if there's missing gaps in data, we know right away that we have to fill out the SSM and get an explanation. So we're staying on top of it, and it's not a mad rush at the end of the quarter to try to figure out why systems were down and get the text back history of the knowledge of the explanation. Mm-hmm.
So as Phil has pointed out here, while this may have a low cost associated with it, there are some significant returns that you can get from this, whether it's the fact that you don't have to go out there and get the data, or you're able to gain more insight from the data from looking at it through graphs or whatever you may find there. If we kind of take one more step up in terms of cost, we're going to get some more benefit, and we'll look at that here on the next slide. So again, one step up from RMC Lite is this concept of around a full-blown cloud-based SCSRMC system for your site. It's your entire landfill integrated together. So with this, the days of having to drive around your facility to manually gather data or check to make sure that your equipment is operating are done. Beyond that, in one interface, you can understand how your facility as a whole is operating. And you can see example of that here on the screen, and Phil will talk you through what we're looking at in terms of condensate levels and how that may be affecting our system in this case.
So on the top graph, you see the spike in condensate, and you see the flare shut down in the blue. So I like to call tail of the tape. When you're watching a football game and you need to, they play a penalty and they slow it up. It's the exact thing that's happening here. We go to the shutdown, we look at that time period, and it points, the problem jumps out at you. We have a blocked header or a blocked system, and we need to address it. And it could be a thermocouple that went bad. It could be a blower. It's go back to that event. Let's look at the analytics on that shutdown, and we can quickly identify the issue.
Yep. And one of the ways I like to look at this is that when we're presented with the option of gathering more data or less data, I tend to try to lean towards gathering more data, because you never know when you may need that one specific data point to help figure out what happened. I know, Phil, you've shared instances where we've used data from systems to size blowers in the future. And we were using data points that when we first set it up, we didn't necessarily know how it may be used, but then later on down the line, we're able to get a good return from that by being able to accurately size this blower moving forward.
A couple of questions for you, David, just to kind of think about this. When,
Sure.
in terms of, we all know things go wrong and systems fail, data systems fail, internet goes down, and you have all these systems that were relying on SCADA, for example, to do that. So if you have a failure, what is the fallback, both from a data perspective and from a response perspective? Is the reaction is that you have a failure, it's not getting data, so a technician gets told that you got to go out to the site, it's a catastrophic kind of thing, or what do we do for fail safe with regards to operating these systems when things go wrong and when data is not being transmitted automatically?
Yeah, that's a great question, and we'll tackle that here in a couple different parts to that question. So around the concept of how do we design these systems with those things in mind, is that's something that we're thinking about as we're designing all of these systems. So part of it comes down to is how important is this data? If the data is regulatory data and something that we need every 5 minutes, every 15 minutes, we need to make sure that we're storing that data locally before we're forwarding it up to the cloud. So we've got the data stored in multiple different points and within that. So we've got it stored locally. So if there's an internet loss, it'll continue to store the data locally. And when the internet comes back on, it'll connect to the cloud and it will forward up the data that was recorded locally when the internet was down up to the cloud, so that your data records are synced at that point. So that's one way that we tackle this. The second way that we tackle this around the how do we react when unexpected things happen, right? Maybe it's what Phil was talking about, that you get hit with some massive storm and all of a sudden there's a big inundation of water, or the power goes out, or what have you. Well, part of the systems that you're seeing here is our SCSRMC service package. And what happens with that is that we have automatic reporting set up on all of this and monitoring, that we know when these systems go down. So before you even know that your system is offline, we're getting alerted saying that your flare is now offline, or we can't reach the modem, or something else has happened. And we will reach out to you and say, hey, we just found out that your flare is down, or the radio's out, or the modem's out, or whatever it is. And we can help you troubleshoot through what's going on to get your system back up online.
Do you routinely have cameras that can help in this process?
Not at every site, but we do have a lot of cameras out around the country, and that can be a very nice way of identifying what's going on at a facility. I know, Phil, you've got several up in Northern California that are used for, I think, liquid level monitoring, right?
Yeah, we have them on ponds. We know sometimes a pond is going to overflow. It's already alarming out, and we're looking at it when it's going to breach. We have cameras for security. We have cameras that we put down. We built cameras to go down probes and wells, and we whether it's a thermal camera or a high resolution methane camera, we invest heavily in the technology, and we're always looking at ways to utilize video.
Yep. And Phil's point there kind of gets back to what I was talking about before on one of the first slides, is that we know that we are in a unique position within the industry, that we want to stay basically as close as we can to that cutting edge without getting cut ourselves, right? And identifying these new technologies that are coming down the line to help really everybody up their game and be proactive instead of reactive, and achieve all those benefits that we were talking about. Any other questions there, Bob?
Yeah, in terms of data security, are you going to get into that in terms of how we make sure our data is secure?
Yep. Yeah, so everything is protected behind firewalls. We use industry standard encryption when we're transmitting the data, and everything is username and password protected. We can even up it beyond that as well, as on a case-by-case basis as it's needed.
Okay.
All right. So speaking of upping our game, let's take a step up. So we were just looking at what one site looks like. You're probably asking yourself, can we combine multiple different sites together? And the answer to that question is yes. So SCSRMC can be configured to allow you to compare data across multiple different sites. And this can enable you to focus your efforts on the real problems across your facilities, no matter where they are. You can also compare one site against another to identify your star performers and those that really need help. So if you're managing multiple different facilities, whether they're right next to each other or they're across town or across the country, we can configure systems for you that can allow you to be able to sort through all that and act on the stuff that you really need to act on. Is there anything you wanted to talk about here, Phil?
Yeah, so we have certain clients that, we have going up the managers, they have whole regions. They could have 12, 28 sites. And rather than a text, maybe he's just associated to 3 sites. So we can have those big roll-up numbers, big alarming per the user that we're targeting.
Yep. All right. So many of you probably saw our first part of this webinar series, and that was really covering the work that RMC does in regards to GIS and drones. And wanted to steal a phrase from one of my friends, RMC and GIS are like peanut butter and jelly. While they're great by themselves, they're best together. So you probably heard me talk about this towards the end of the GIS and drone presentation. But to bring this point together here again is we can really stick these two systems together and get the best of both worlds. So RMC is best at fully automated data collection and control, like we've been talking about. And where GIS and drones really excel is that they're best for more infrequent data collection. So if you need data every minute, every hour, every 15 minutes, something very frequent, RMC is your best bet there. If you need data maybe once a week, once a quarter, once a year, GIS and drones can be a really great option there. And then the best part about this approach is that it doesn't matter where this data is coming from. It can be pulled together into one dashboard like we were talking about before, where you see everything together in one spot so you can manage your entire facility through one interface. And what you're looking at here is a 3D visualization using our GIS software. And I think Phil will give you a better understanding of what we're looking at.
Sure. So the big black box is looking subsurface into your landfill. So we created a tool to visualize that. So we take the drone's ortho data, the imagery, we take the DTM, the digital terrain model, we take your bottom surface, the as-built data of the well, the liquid level we're collecting either by a sensor, a technician going and sounding it, and we're putting that all together to visualize and solve problems that we know where to place our pumps, we know what pumps aren't working, we know where to address this. And this tool's, it's already created, we just feed the data to it and it builds itself. Whether you're collecting the data minute by minute, weekly, quarterly, monthly, yearly, it accepts it and it's on the fly. We don't have to manually go and rebuild this 3D model every time. And we're offering this in our GIS package.
Yep. And this, whether it's this by itself or combined with the RMC systems we've been looking at, again, it can be provided all together in one package, and that's where you're really going to get the most bang for your buck, so to speak.
Hey, Dave, I want to add, so if you're looking at the screen, we're looking at a couple of wells, and 85 here, the red ring represents where the pump sits. Obviously, the blue's the liquid level. That pump isn't working, and that's how we quickly identify it. You can see a couple pumps that need to be serviced. So we know right away, they pop out, we have that list for the maintenance crews to go pull the pumps. Let's get these green again.
Yeah, and that gets back to that overall concept that we've been talking about of being proactive instead of reactive. That, yeah, that blue column is up there fairly far, but at least it's not like completely covering up your perfs or fully inhibiting your ability to be able to collect gas there. All right, so moving on to another application that we've been working on. Carbon credits can be a great way for a site to reap the benefits of early landfill gas collection, and pairing gas analyzers with flow meters with the Internet of Things or IoT equipment allows you to be able to have your carbon credit data at your fingertips and the knowledge that your carbon credit data is recorded automatically and backed up. So this gets back to what Bob was asking about before. With these carbon credit monitoring stations, we're recording the data there locally at the site and streaming it up to the cloud. And beyond that too, we didn't cover this in the earlier discussion, we're backing up that data. So we've got the data stored in at least 3 different spots. So you can rest assured knowing that your data is safe and secure. And you can see here on the screen an example of how the system was operating. This actually comes from a site that we're operating the carbon credit monitoring station for. And we're using our own equipment and our own technology here for our own projects as well. So the final application that we wanted to go through is one of the things that we get asked for very frequently, and it's around the concept of monitoring pressure, temperature, and oxygen. And we're happy to say that we now have IoT-based solutions for all of this. So we've got a low-cost, intrinsically safe pressure monitoring solution. We also have a landfill gas temperature monitoring solution. And thirdly, we've got a low-cost in situ, or actually measuring it within the pipe itself, oxygen monitoring solution. And I'll let Phil talk about a couple more aspects of this.
Sure. So the big change I see, 10 years ago, an oxygen sensor, it was 5K plus, it was high maintenance. Now we found tunable diode oxygen sensors. They hold up, they require very little maintenance, just yearly calibration. And we're putting them, in the wells. Let's talk about the vacuum sensor. There again, vacuum sensors used to be really expensive. We found a low-cost vacuum sensors. They're holding up to the elements. We're installing these in the field to know when a cell's down, certain headers, certain wells, so you can put them all over the landfill. And then Dave, you have a lot of experience now putting temperature sensors down the well. It used to be you threw a thermocouple down your well, you sent a technician, and he would go monitor that once a day if we're looking at wells. Now we're getting minute by minute readings with these temperature sensors, and they're low cost. They're holding up.
Yep. So I think you'll hear more from us here over the coming years about that.
I got a question for you. I mean, I'm working on a project now, and just landfills and landfill gas is a tough environment in terms of on electrical equipment, sheathing. It's corrosive, and even the physical configuration of things. So you put a probe into a gas well, in terms of how far you go into that gas well with your probe may affect the relevance of that information. I'm just curious in terms of how you take that into account. I know on one particular site, we were just involved with the original monitor probe was, I'll call it a 1/2 inch long, and we were getting ambient temperatures affecting it. We went ahead and put like a 2.5 inch probe in, and it started to actually, capture more realistically. And so what are some of the challenges in the environments that we work in, and how are we trying to solve those?
Yeah, landfills are a unique beast. And one of the things that I think I'd encourage everyone, whether it's us or other people, if you're looking at applying a new technology, I'd encourage you to make sure that you've got landfill engineers that have experience working within the landfill industry helping you with that. Because to Bob's point, there's things that a normal civil engineer or mechanical engineer would never think of because they haven't been exposed to landfill gas or to leachate. And some of the big issues that we run into are around the compatibility of materials with whatever it is that we're exposing it to, whether it's leachate or condensate or landfill gas. I'll actually be talking about that specifically in about 2 or 3 slides. And then Bob's right. We did just run into a case where we had to extend a probe because the way that the wellhead was configured, there was more effect from the ambient environment than from the landfill gas itself. So the cool thing about it is that we're able to work with our clients and with manufacturers to get the right equipment in there. And I'm happy to say that we've got the right stuff ordered, and we've got a couple of them installed now.
So we do methane monitoring too, these sensors?
Yeah, we do have a few. It's not here on the screen, but we have some solutions around that as well. What we were looking at there on the carbon credit slide had a methane sensor associated with that. You can see that there on the gas composition part right there.
Yeah.
Okay. All right, so we've been talking a lot here so far about landfill gas. Obviously, it's a big part of what SCS does, big part of what RMC does. The next couple case studies here will focus on some other aspects of what RMC does in the broader industry. All right, so the first one is around a project that has been active, I think, for the last 5-6 years or so. It was one of the first ones that I put in with Phil. And it's been one of our more successful projects as well. What was going on at this facility was that they are doing fumigation at the facility. And they were ordered by the state to pull ambient air samples every single time that they were doing a fumigation event. So they were spending somewhere north of $1,000 a night by the state mandate of having to have somebody go out there, get a bag sample, and then send it off to a lab. And there's all sorts of issues around shipping gas and all that, but they'd have to send it out to a lab. They'd have to wait for the results to come back. Then they'd have to prepare a report and submit it to the state. So it was costly. It was time, took a lot of time to do it. And it was not the best possible way of doing this. So we worked with the client in this case. We worked with our engineering side of SCS as well. And we came up with a solution that put in 7 different stations around the perimeter of this facility where we were monitoring for that fumigation chemical. And we were taking readings every minute, and we were streaming that data over a radio network back to a central location where we had an IoT device that was, again, recording the data locally and streaming it up to the cloud. And what we're getting out of that system are a couple of different things. We're getting alarms out of it. So if the measured fumigation levels exceed some set points, there are alarms that are sent out alerting the staff and our team to that. And then we're also generating these automatic reports like the one that you see here on the screen. So these automatic reports are summarizing the previous 24 hours of operation, and it's showing at each location the maximum chemical concentration and the maximum rolling 1 hour average chemical concentration as well. And then it's showing the corresponding date and time of those maximums, and then the wind speed and direction of when those readings took place. So essentially we can know if there is a problem with the fumigation system, how much of the chemical was released and kind of where it went. So it gives you a relative impact. And then this report is automatically sent out per the state's guidance. It's sent out to them, it's sent out to the client, and it's sent out to us as well. And this has been in continuous operation for the last 5 or 6 years now. And the key takeaway from this is that RMC systems can have tremendous payback periods and give you the ability to give accurate, timely, periodic, and transparent reports to regulators and to internal resources as well. So specifically for this instance, they were paying about $1,000 a night before the RMC system went in. The RMC system cost roughly about $90,000 to put in, including the sensors and installation and all that. So the payback period on the system was about 3 months. So they've definitely reaped a lot of benefit, both from the financial aspects and from working with the state and continuing to be able to operate as well. So big success story here. All right, let's move on to the next one. So liquids is a big part of what we do within SCS. It's a big part of the issues that face you, our clients, and it's a big part of what we do within the RMC group. So what you're seeing here on the screen is a fairly simplified P&ID of landfill leachate collection system. So all the leachate from this particular landfill goes into one very, very deep manhole. You can see that there on the left. It gets pumped out of the manhole up through an inlet flow meter there where Diane's cursor is, and then it gets discharged into this tank where it's held for anywhere from a day to a couple days, and then it's tankered off-site for treatment and disposal. So there's a couple different things that we did with this RMC system here. We have it set up so the initial use for it was that the truckers would be able to log into the system to see what the liquid levels are, and then be able to know when they should come out to the facility to take liquids. We also are using it to monitor the amount of flow that's coming in and out of the tank. And then since there's those flow meter enclosures there, we noticed that there were times when those flow meter enclosures, the heaters that were in them would shut off, that there was too much current that was being pulled by the heaters, and the breaker would trip, and then the heater would just go off and there'd be no heat. So to help be proactive instead of reactive with these problems, we installed thermocouples in both of those flow meter enclosures that are telling us on a minute-by-minute basis what the temperatures are within those flow meter enclosures. And the cool thing about it is it actually catches two potential problems in one. First one is around the heater tripping out like we were talking about. And then the second thing that's happened every once in a while is that somebody will be out at the site inspecting something, and maybe they forget to close the door to that flow meter enclosure. So in either case, your temperature is going to drop, and we set an alarm on that thermocouple that says if the temperature drops below, say, 45 degrees, then an alarm goes out and the technician's dispatched to the site to figure out what's going on, whether it's a heater issue or whether somebody left the door open or maybe something else happened at the facility. And the cool thing about that is that we're preventing those pipes from freezing and spilling leachate on the ground and creating a big environmental problem there. So all that's being accomplished by essentially just thermocouples and an RMC system. Now, the other really cool thing I want to point out and talk about here is around those flow meters. So after the flow meters were installed, we were monitoring the amount of liquid that was being taken on an instantaneous basis through that inlet flow meter, and it was right around 100 gallons per minute for several months. And then we saw the flow really start to drop off very steadily over time. So it was 100, 98, 99, 97, just kept on going down, eventually got down to about 80 gallons per minute. And we're like, okay, this isn't some sort of temporary thing. Something's up with this. We need to go out there and check it out. So Diane will flip to the next slide here. First thing we did was look at the flow meter itself. So I was the one who went out there and actually did this. And I spun the flow meter around on the bolts, and the inside of this flow meter when it was installed was like bone white. It was the color of white that you see there in basically like the donut shape. And it was completely coated with Teflon. And I can bet that you guys all know what's inside there. It's the wonderful leachate black goo that many of our landfill sites have here across the United States. And it had completely coated the inside of this flow meter to the point that it was inhibiting the ability of the electromagnetic flow meter to accurately record the amount of flow that was being taken through the flow meter. So to help fix that problem, yours truly took a toilet brush to it, and Diane can show you what that looked like. Got it mostly cleaned out there, and after I got it cleaned out and reinstalled, it was back up to 100 gallons per minute. So we did two things once we figured this out. We instituted a bi-yearly cleaning on the flow meter. So again, we're trying to be proactive instead of reactive. And then we set up an alarm on the inlet flow meter so that if the recorded flow drops below 90 gallons per minute, we know about it and we're able to go out and act on it before that flow meter gets to the point where it's completely off basis. Phil, is there anything else that you want to talk about here?
You know, we tend to spec out magnetic flow meters because not a lot happens as far as what you just, this is kind of out in the ordinary. I don't see too many mag meters that get plugged rather than turbined. You know, our leachate mucks them up. But this is a really good example of, you know, mag meters do need maintenance, and we tend to go with mag meters, but we just can't leave them alone. I like what you implemented here.
Thanks. We had another instance, you can jump backwards, Diane, where we had literally just installed an RMC system. It was, I think, operational for 15 minutes, and we were looking at very similar to this, the amount of flow that was leaving the pump station. And we were also looking at the pump statuses, and we were looking at the level in the pump station. So through the RMC system, literally within 15 minutes of doing this, our now senior project manager, Sam Rice, was standing out there and was looking at the interface and was seeing that both of the pumps were running, but the level was going up in the pump station. And there was like next to no flow that was being shown on the flow meter. So they very quickly figured out what had happened was that one of the force mains was clogged. Actually, I think only one of the pumps was running at this point. So they switched which pump was active and basically backfed water through this force main, and they're able to break loose a clog. And literally that 15 minutes of the RMC system operating prevented that pump station from overtopping and spilling a bunch of leachate on the ground. So it's another related success story here. So the key takeaway that I wanted you to take from these stories is that RMC systems give you the ability to be proactive rather than reactive. And this applies to any type of RMC system, not just the ones here for liquids management. So the final case study that we want to run through is around liquids monitoring and specifically loadout monitoring. So we've implemented several liquids loadout monitoring stations. You can see an example of this here on the screen. Through this, the site and haulers can know exactly when loads need to be taken and track who's taken those loads and how much they've taken. And these systems can be equipped with dashboards like the one you see here on the screen and automatic reports and alarms as well. Phil, is there anything you wanted to touch on here?
Sure. So these trucks are being alerted through text, email, and sometimes calls, depending on the severity. And as you know, in California, we're getting a lot of rain. We can historically look at the amount of inches we're getting, and they forecast the amount of trucks they're going to need in certain rain events. So these haulers are living and dying by these systems, and the client is better prepared to get this liquid out and to be treated.
Yep. And we built this dashboard around that whole concept that we wanted to work for both the haulers and the client. So we've got here on the left, we're looking at the vertical liquid that's within the tanks. We've got the graph of the tank level over time there across the top. Below that, we've got a record of how much flow was taken when. And then down there in the lower left-hand corner, and I happened to grab the screenshot a couple weeks ago, on this particular day, no drivers had taken any flow. But the way that this works is that those little trucks kind of fill up with water depending upon which driver has logged into the system. So there's an interface there that allows you to enter your little PIN number and say, okay, I'm driver 1, I'm logging in to take my load, and it'll log that load as being driver 1's load. And then the client can take this information and compare it against their manifests and invoices as well. So the key takeaway here is that RMC systems enable you to provide services just in time and have thorough and accurate record keeping. Okay, so to start to wrap things up here, we're going to run through some of the newer things that we've been working on here. So one of the things that has been changing within the industry over the last several years is around composting. That many of you have compost facilities now, or maybe you're considering compost facilities. And we've got a Compost RMC concept here that we're looking at. So basically one way to think about it is that it's RMC brought to bear on the compost industry. So we're using all the same RMC technology that we've been talking about to operate and monitor your compost facilities. So through your Compost RMC system, and Diane, you can flip to the next slide here, you'll be able to incorporate data from wireless or manual temperature probes, air monitoring equipment, weather stations, electronic forms, and other equipment. And you can also control your blowers, valves, pumps, tanks, anything that you need to control out there at your compost facility directly from your RMC system, whether it's through your phone-based interface you see there on the right, or whether it's through your computer that you see their example at the center of your screen. And similar to other RMC systems, you also get reports and alarms to help you be proactive instead of reactive. And again, we're designing these systems to meet the needs of the compost industry. And we're excited and happy to get feedback on these systems here as we move forward.
Hey, Dave, on the drone side, we're flying the compost piles for stockpile to know how much quantity. We're flying them for methane, if they're producing any methane, or the ponds, the liquid that's dropping out. So there's a couple applications on the drones that we're implementing to help out the facilities.
Yep. All right. So similar to composting, anaerobic digestion is an area that the overall industry is adopting more and more. And because of this, we're developing applications to help optimize their operation. Our approach focuses on giving you automatically the data that you need, rather than you having to go out there and get it. And also giving you the ability to be able to automatically and remotely adjust your operations based on that data that we're collecting automatically. And we're working with one of our national clients and our liquids management and wastewater team to implement this solution. All right, so to bring us home here, Phil's going to run through some of the real key benefits here that we see with these RMC systems.
So our instantaneous notifications, whether it's text, email, or the roll-up reports, all this data is being collected, and we're troubleshooting issues. We're saving the client's time, saving our technicians' time, our project managers. We're visualizing what normally could have been seen with the GIS system. We're looking at subsurface. I talked a little bit about these roll-up reports. We customize them per the client. You give us the numbers and your calculations, and it could be as simple as big liquid roll-up numbers, or numbers that have to be reported to the state or the regulators. At the end of the day, we're reducing your O&M costs. We're doing a lot more with technology, and the cost is coming down. The health and safety aspect, when we restart a flare, we have the lockout, tagout, and we're reducing our risks and our health and safety and keeping everybody in compliant. And the overall quality of life, I shared that story about Christmas. That's what it's all about, spending time with our family and just doing more technology.
Yep. So really, I think this gets back to what we were talking about at the beginning, that we're here to help you solve your problems, and we're using that lever of technology to try to do that. So we'd love to hear any questions or comments that you guys have now.
I have a question. With respect to lessons learned, I mean, you've obviously put in a lot of these systems. You've probably done some things and said, that didn't work. We're not going to do that anymore. Are there any of those kinds of things that you think this group might be interested in hearing in terms of lessons learned, or things to watch out for or not do, or don't waste your time on, or money, it's a waste of money kind of thing?
Yeah. I'll give one thing and let Phil jump in here with some other thoughts. One thing that I think we've learned here over time is that even when you're adding stuff to your control systems or your SCADA systems or RMC systems, you need to be careful with what technologies you use and really understand the specifics of the technology that you're implementing. It gets back to a couple different things here, that if you're not careful with what you select or how you do it, you can end up with garbage in and garbage out. That if your sensor is not accurate, or you select the wrong type of sensor, or it's not installed properly, or it's broken, you're going to think that your system is operating fine when in reality it's not. So keep that in mind as you're doing it. Work with somebody who knows what they're doing, and make sure you're getting stuff that really makes sense.
I think scalability, when you select a PLC or a sensor, you got to be sure that manufacturer can produce it in the quantities you need. And, with supply chain issues, we're seeing a lot of, chips that we can't get, a lot of PLCs we can't get. So when you align yourself with the manufacturer, look at their quantities, look at their ability to their support. It's super important, because we're nationwide and we're servicing a lot of sites, and no one wants to hear we can't get a part.
Yeah, and similarly too on the software end of things as well, aligning yourself with someone who, and a software package that has nationwide and broad support as well. That the last thing that we want to do or have you guys get stuck with is something that's not supported, or is only supported by one person, and that person goes out of business, and now you're stuck with this thing that doesn't do what you want it to do, and there's nobody there to help you fix it.
Let's see, does RMC have a data monitoring and tracking package for Windrows composting for the Southern California market?
Yes, that's what we were just talking about there. So we're actively working on not actively working on, we're hoping to get notice proceed on one for Northern California here in the next couple of days. And we're exploring opportunities throughout the US as well.
We've implemented Windrows systems in LA County, Orange County, and soon to be San Bernardino. For odor complaints, odor management, the Windrows can be used for a lot of different applications.
Yeah, because typically on Windrow, you're looking at the moisture content, the heat, temperature, in order to make sure the piles are being managed correctly. So that's useful information for sure.
Yep. Yeah, that concept that we were looking at, I know we didn't get into a lot of detail with it, but it's meant to manage your entire composting operation. So you can track when it was created, when you added water to it, when you turned it, any other notes. If there was like an event with high wind or a lot of rain, you'd be able to enter all that information into the form.
So I'm a landfill manager, and I've got a landfill. It's 100 acres, and so I've got let's say I have 70, 80 wells on this thing, and I want to put RMC on there. What does that look like in terms of, do we have a sense, or can we give kind of ranges of, what are we talking about? 5,000, 10,000, 50,000, 100,000? What ballpark do we need to be thinking relative to the RMC side on a capital perspective? And then going forward, obviously they don't run themselves, so to speak. They got to be maintained.
I think the first question is your existing system. Do you have weather stations that are they 30 years old, 15 years old, 10 years old? You know, your flare stations, same thing. What are the age of them? A lot of times, if it's within the last 5-10 years, it's a quick retrofit. So it all depends on the age of the systems that we're tackling.
Yeah, and we're looking at sites with dozens of different data collection points. And if the bigger the site gets, obviously the more expensive it gets, but the price per point comes down as well, because there's efficiencies with putting lots of stuff in at the same time.
So Phil, you're basically saying like it's like the beta versus VHS tape kind of thing. You know, depending on where what era you're born in, they may not talk to each other.
Sure.
Okay. I don't know if there's any other questions from the audience. I see for the power plants, question mark.
Yeah, so the answer is yes. We're implementing one right now, and we've done several other ones in the past.
Whether it's, you know, an RNG, you're producing, you have cat generators. We do all types of power generation.
Yeah, we're working on another cool related project where we're monitoring, similar to the carbon credit example that we gave, different gas collection points around a landfill that's feeding gas to one central facility like that too. So we can tie the landfill end of it, Bob, to your point, into the operation of the RNG or landfill gas to energy plant.
Yeah, I mean, my experience has been on RNG plants and those things. They generally have some type of SCADA system already, you know, a part of their world, or designed into that. And if we're in the middle of the design, I know our energy group does a whole series of things on SCADA. And
yeah, and one of the I think other points I want to drive home with that too is that example that we were looking at before of the condensate level versus flow. That was a literally actual example of where the condensate level feeding this thing got so high that it cut off the flow of gas. So if that happened to be an RNG facility, you're out thousands and thousands of dollars because your condensate level and your whatever it was sump got too high. So it's important to look at these things as a whole, not just individual parts and pieces of, like, I've got my SCADA system for my leachate plant, I've got my SCADA system for my RNG plant. We want to look at everything together in one spot so that we know how all these things play together.
so we talked about the fact that you put these things in, they don't run themselves. What type of support do we provide to maintain these systems and make sure they're operating correctly?
Yeah, we call it our RMC help team. They're on call 24/7. We've got email and phone-based support for that. And then we've got proactive monitoring set up as well. So they get alerted when there's a problem, both from people calling in or emailing in saying there's a problem, and from our proactive monitoring that tells us when something goes down.
On the software end, we're constantly updating, you know, the SCADA systems, GIS, the security of the firewalls need updates, the modems need updates, and sometimes they're automatic. Sometimes we have to manually go in there and update those software packages.
This is a question I haven't really thought about. Is there any gas flow direction sensor that can be put on a header? I guess it's almost like a Hardy Cross water flow question in terms of, I guess if you had a system where you had a header where flow could go different ways, depending if you block one off, you know, cut off the side of a well field and out reverses around. Have we ever done anything like that?
Like a loop system, if you have a loop system.
Yeah, so in some cases you might have gas flowing in a couple different directions depending on what you're doing on the system if you're maintaining it.
Essentially, we do, because we're looking at flow and vacuum, and if you reverse it, we're going to know it'll go, you know, your vacuum sensor will go positive and your flow will go zero, right?
Right.
Yeah, it probably depends on the type of flow meter you're using, but yeah, we could come up with something for that.
Okay, well, it's an interesting question.
Yeah, and those are the types of questions that we love getting, that you see how excited Phil is right now, that he literally lives for this type of stuff. So if you've got off the wall questions like that, we'd love to hear them.
So, good question here is in terms of, is the stuff we're doing proprietary?
Yeah,
No.
so, well, I guess it is and it isn't. That it's something that we own. It's our intellectual property, but it uses commercially off the shelf software to support it.
Does that make sense, Phil?
Yes, so like Dave said, we don't like to put in a proprietary sensor that no one else can get. We like to build stuff that you can maintain. If SCS, we part ways, you have a list of components you can get with model numbers and replace that. So to keep your system up. So yeah, with some of like the 3D wells, that would be proprietary. We invested in that software. And that's something that's unique to SCS.
Yeah, this is a good question. And I thought about this too. You know, sometimes we become slaves to the equipment that we put in. In other words, we spend more time maintaining it than it was just, you know, it's creating work. And so somebody from the city of Baltimore said that the data is good and we're using it, but too much repair is needed. How can we avoid repair problems? That's a great question.
Yeah, so it gets back to probably the design of it and making sure that you're using sensors and things that are appropriate for the environment and trying to design around the pitfalls there.
And, you know, so if you're running industrial computers in an environment that's dusty and say your operating room is not air conditioned, and the right environment for like the head end systems is important. You know, you have maintenance on filters and air conditioners, and the gentleman that asked that, it's totally correct. You got to stay on top of the environment of any system.
Yeah, I do a lot of woodwork and I'm continuing. It's always amazing to me, you know, the dust, just that dust and what impact it has on some of the equipment that I'm working with, that you got to be really careful of, because it can create some real headache if you don't watch out. Again, thanks for those who attended. We appreciate your attendance and hopefully you enjoyed it. Thanks so much. Phil and Dave, thanks.
Thank you.
Thank you.
Bye.
Have a good day.